Hello students, in this video we will be learning about maximum and minimum values. If you haven't watched the video on bounds or aren't familiar with bounds, I recommend you check out that video before continuing. So the aim of this video is to help you become more confident using upper and lower bounds to find minimum and maximum values. So to begin with, we're going to be looking at multiplication. Looking back at rounding though, when a number is rounded, lower and upper bounds are created if we do not know the original number. If we use the lower bounds or upper bounds, we will get different answers in our calculations. This is why we can find maximum and minimum values by using a specific combination of upper and lower bounds together. So when multiplying, we use both upper bounds for numbers to find the maximum value, or as many upper bounds as we're able to use to find the maximum value. And when we want to find the minimum value, we multiply as many lower bounds as possible, as this would give us the smallest value. So let's have a look at an example. So if we have a look at this question, it says John measures the length and width of his garden to the nearest metre. So here, these are his measurements here, 2 metres and 6 metres. Find the maximum value for the area of his garden. So it's always a good idea to write down the bounds for both of them. So for the width, the higher bounds or the upper bounds would be 6.5 and the lower would be 5.5. These are in meters. And now the height or the length of his garden, the upper would be equal to 2.5 meters and the lower would be equal to 1.5. So if you have a look at question A, it says find the maximum value for the area of the garden. Now, to find the maximum value, we have to multiply all the upper bounds we can. And we know that to find the area is width times height. So to find the total area of the garden, and we want it to be the maximum value, we have to use both upper bounds. So the upper bound for the width is 6.5. The upper bound for the height or the length is 2.5. And this will give us an answer of 16.25 meters squared. Don't forget the squared, because that shows that you're measuring area. Now question B is asking for the opposite, is asking for the minimum value for the area of the garden. And if you remember, we need to multiply both lower bounds. So if we look at the formula again for area, it's width times height to calculate the area. And we need to use both lower bounds to find the minimum value for the area of the garden. So the minimum value for the width could be 5.5 and the minimum or the lower bound for the height or the length is 1.5, and that would give us a value, if we multiply these together, of 8.25 meters squared. Alright, so now we're looking at dividing. Now dividing requires a different approach. We still depend on the upper and lower bounds of rounded numbers, but to find the minimum and maximum values, it is slightly different. So to find the maximum value we use the upper bound divided by a lower bound number, and to find the minimum value when dividing, we use the lower bound number divided by an upper bound number. Okay, so here's an example of a question you might see. We first want to find the upper and lower bounds of the measurement we have. So it says here that Gary took his measurements to the nearest metre. Find the maximum value for y. Okay, so we first need to recognise which formula we're using, and we're not talking about lower bounds yet, just the formula for the area. So we know area is width times length equals area. But here we've only got the area and the length or width, so we would have to divide it to find y. So y would equal area divided by the width. And to find the maximum, we have to put the upper bound, so maximum values would be upper divided by lower. That's how we would find our maximum value. So the area goes on top, so what's the upper bound for our area? the upper bound is 24.5 because it was rounded to the nearest meter. So we can write 24.5 on top, and we need to put a lower bound, which is our width, on the bottom. So what's the lower bound of 6 when it's rounded to the nearest meter? So let's remind us this is the upper, and lower would be 5.5. So 24.5 divided by 5.5 would give us an answer of 4.45. So let's have a look at question 2b. It's asking us to find the minimum value for y. So if we have a look at our formula again, it's still y equals area over width, but this time we want to find the minimum value. So our formula now for min is we use the lower bound on top and upper bound on the bottom. So we still need to put the area on top. So what's the lower bound of the area? Well, the lower bound of the area this time is 23.5 because it's to the nearest meter. Because if you round 23.5 up to the nearest meter, it would give us 24 meters squared. So 23.5 would go on top, and the upper bound for the lower, which is still the width, the upper bound for 6 would be 6.5. So 23.5 divided by 6.5 equals 3.62 meters. Okay, here are some questions. If you want to try them out yourself, feel free to pause the video now. I'm going to go through the answers. Okay, so the first question is telling us that the measurements for the paper are to the nearest centimetre. Find the maximum value for the width of the paper. So we can write down x because we want to find out the width of the paper. Alright, so we've got 100 centimetres squared and 30 centimetres for the height. This is the height. So I already know to find out the width we would use 100, which is the area, divided by 30. But this is not all we need. We need to use minimum and maximum values. So to find the maximum value, remember we do upper divided by lower. That's how we find max values when dividing. So the upper value of 100 when rounded to the nearest centimetre would be 100.5. And the lower value for 30 centimetres could be 29.5. And when calculated, we get 3.4 centimetres. If we have a look at question 1b, it says Alan measures his pool to the nearest metre. Find the minimum value for the area of his pool. So if we have a look here, we're given 10 and 20. But when we want to find the minimum value when multiplying, because this would be a multiplying, we have to use the lower bounds of both numbers. So to the nearest metre, 20 metres, the lower bound would be 19.5. And for 10 metres, it would be 9.5. And then all we need to do is multiply these two numbers together to find out our result for the minimum area of the pool. So the answer would be 185.25 meters squared. Right, thank you very much for watching. For more videos, please visit www.gcsemathresources.co.uk.